Good evening. So here are another example of flight of projectile. How to solve the flight of projectile. So let me start at the number 1. A group of children are throwing balls to 0.72 inner diameter tire hanging from a tree. So a child throws a ball with an initial velocity at an angle of 3 degrees with the horizontal. To determine the range of values of initial velocity from which the ball will go through the tire. So paghagis nung bata dito ng bola, pwede siyang doon dumaan sa point B or doon sa point C. Doon sa edge ng inner diameter or doon sa rim. This is the point B and the lower is the point C. So the inner diameter has the opening of 0.72 meter, and from the ground, from point C to the ground is 0.25 meter. Okay. So first, the range of velocity is what will be the velocity of the ball when it hit point B and when it hit the point C. So we will establish that range later on. So first, establish the component of velocity along x and along y-axis. Along y-axis, this is velocity initial sine 3 degrees, and that is equivalent to 0.052 velocity initial, and along y-axis is velocity initial cosine 3 degrees. And this is 0.99 velocity initial, or 1 multiplied by velocity. So establish the horizontal equation that we will get on the flight of projectile. So we have x is equals constant velocity, ax multiplied by time, from point A to C or B. So this is the x. So we'll represent it as x equals 6 is equals. So this value is what we get here, dO multiplied by time. Therefore, the time of the whole flight from A to C or B is equivalent to 6 over velocity initial. Then let us proceed to establishing the equation along vertical component. So vertical flight so we have this equation along vertical. Final velocity is equals initial velocity minus gt, or final square minus equals velocity initial square minus 2gh, or final velocity square sine square 3 minus 1962. Then whichever height, C or B. That's all. But Para madali, consider the point B. So the point B, the difference of T elevation of P and point A is equals 0.53. So the difference, this difference, because you establish your axis here. This is x-axis and this is y-axis. And this is the origin of the particle. So below, the distance below this origin will be negative. So from point B and point A, so 1.5 minus 0.72 minus 0.25 that is 0.53. 0.53. So YB is equals velocity along y-axis multiplied by t minus 1/2 gt square. So let us substitute. Since the point B is below point A, this is negative 0.53 equals, so yung velocity along y-axis is 0.052. 0.052 velocity initial so yung time ay equivalent ng 6 over velocity initial minus. So this is 4.905 6 over velocity initial square. So when we simplify, we can cancel it. Then negative 0.53 equals 0.312 minus 176.58 over velocity initial square. Okay, rearrange. This is 176.58 transpose equals 0.312 plus 0.53 velocity initial square. So the velocity initial will have the value of, this is 176.58 over 0.312 plus 0.53. So velocity initial is equals 14.48 meter per second. So when it hit the point B, so consider point C. So YC is equals velocity initial along y-axis minus 1/2 gt square. So point C is lower than 0.53 plus 0.72 than A. This is negative 0.53 minus or 1.5 0.72 plus 0.53. Okay, 0.72 equals 0.052 initial velocity. This is 6 velocity initial minus 4.905 6 over velocity initial square. So this is negative 1.25 equals 0.312 minus 176.58 over velocity initial square. So again, when you rearrange that, velocity initial is equivalent to 176.58 all over 0.312 plus 1.25. And this is equals velocity initial equals 10.63 meter per second. So therefore, the answer is velocity V, velocity C. This is 14.48 greater than initial velocity. So that is the range, 10.63 meter per second. And that is the answer. Okay, so let us go to example number 2. A volleyball player serves the ball with an initial velocity of magnitude 13.40 meter per second at an angle of 20 degrees with the horizontal. So determine the if the ball will clear the top of the net. Okay, so this one is point C. So let us establish this as point B. And this is point D. Point D, point C, and this is point B. Okay, what we have known, so from A to B, the horizontal distance is 9 meters. Let's say this is from A to B. So the answer is 9 meters. So let us answer letter A. We'll determine first the velocity initial along x-axis, and that is 13.40 cosine 20 degrees, and that is 12.60 meter per second. And along y-axis, 1340 sine 20 degrees. This is equals 4.60 meter per second. Okay. So at letter A, let us consider the vertical flight. From A to B. Okay. So establish first here our axis. This is y and this is x-axis. So this is our reference. Okay. So YB is equals location of particle at the origin plus BOY multiplied by time minus 1/2 GT square. So this is considering from A to B. Okay. So let us level it as ito. HB that is unknown. That determine whether the ball clear the top of this pole or the net. So if it's past the point B, it clear the net. That when the ball hit the point C, it will not clear the net. So the location of the ball at point A is 0 plus BOY. This is 4.6 multiplied by time from A to B minus 4.905 time A to B square. So we have the unknown to unknown. But from the horizontal flight, we can determine the time because x from A to B is equals BOX multiplied by time. And this is equivalent to 9 meter is equals velocity along x-axis is 12.60. So from A to B, the time is equals 9 over 12.6 and that is 0.71 seconds. So therefore, HB is equals 4.6T multiplied by 0.71 minus 4.905. So this is the half of 9.81. And this is 0.71 second square. So HB is equals 0.79 meter. Okay, what we have here is HB plus 0.33 to 0.33.79 no. HB, so this is the YB. YB is from this datum up to B. That is the HB. YB, sorry, not HB. This is the YB. Because we have the reference from the datum, this one, and that is the difference, 0.79. And HB is plus so this amount is equals 2.43 minus 2.1 is equals 0.33. This one, 0.33. So HB plus 0.33 is equals 0.79. Therefore, HB is equals 0.46 meter. So we can say that the ball will clear the net by 0.46 meter. That is answer. So letter B. Letter B question, how far from the net the ball will land? So this distance, what is this distance? So let us say this is from B to D. Letter D. Okay, you can consider this point, the horizontal component of velocity along x-axis is 12.60. 12.60 meter per second, and at point D, this is 12 meter per second. Okay. So because obviously, let us determine if the value of vertical velocity at point B is going up or going down. Okay, so B, that is the final, is equals velocity at A, Y, that is the initial, this is final velocity, this is initial, minus GT, or minus GT. So the time from A to B is 0.71. So B, Y is equals 4.6 minus 9.81 multiplied by 0.71. So B y-axis is equals negative 2.37 meter per second, and that's indicate going down velocity. So this is going down velocity of 237 meter per second. So let us determine the velocity at D, vdy. So again, the final. So we cannot use this formula, but instead the other one, the VF square is equals VO square minus 2GH. And that representing final VDY square is equals. So this time, if this is D, point D, this is point B. And this height is the vertical height from B to C. That's one. This is B, and this is point D. We have the distance here from here. So this is 2.43 plus 0.46. And that is 2.889. 2.89. Okay, this is 2.43 plus HB. This one. So this is 4 point or 2.37 minus 2. This is 9.81. And this 2.89. So when you compute that, this is BDY is equals 7.90 meter per second.